So welcome to the water testing portion of Clean Water. I want to direct your attention to this picture here, where this picture and another one we're going to show begin to tell the whole story about clean water. This woman is collecting water from that lake. She's taking that water to her household where she's going to cook and bathe with it, and her family is going to do the same thing. But the important thing to note about that, there are two things really. One is you've got cattle that are doing something in the water. They're putting their droppings in there, and those droppings are fecal droppings, and we commonly call that poop. That stuff is in this water that she is now collecting. And so that water is contaminated heavily with fecal contamination and coliform contamination, because coliforms are the bacteria that are in your gut, and they're the ones that you don't want in the water. The next picture shows a boy standing on top of a spring outlet. That water that's coming out of that outlet there looks crystal clear. But I know that that water is contaminated with coliform bacteria. Why? Because I've tested one like that and 8 others all around Rwanda, and I'm here to tell you they're contaminated. So the problem really boils down to the notion that if you want to know something about what's going on with your water, you likely need to be testing it for coliform bacteria. So what I'm going to do today is I'm going to show you how to assemble a kit that will allow you to test for coliform bacteria. And then I'm going to show you how to use the components of that kit to test for coliform bacteria. And then you in the audience are going to get to run through it once with me coaching you. But in the meantime, let's talk a little bit about coliform bacteria. Coliform bacteria, when found in water, also indicate the presence of other pathogens that cause disease. Diseases such as diarrhea, dysentery, and other things like that. The causative organisms are going to be organisms like Salmonella, E. coli, and cholera. Everybody knows those organisms and those diseases are deadly and can be deadly. So the water testing, why would we want to test the water when you can see that one of them is perfectly clear and the other is obviously contaminated with algae and fecal matter and everything else? Why would you want to do that? The answer is it provides certainty. Certainty based on science can motivate behavioral change, and that's what we really need to do here. It's not just behavioral change to use a water filter, but it's behavioral change to get people to maybe be more effective in their hygiene as well. So, I'm going to now show you the elements of this kit, and I'm going to start with showing you what it looks like when it's complete and ready to be tested. This is a sample of a water that is ready to be incubated. And you can see it's in a plastic bag. The bag is sterile. This is what it looks like before it's filled. And the growth media that is placed in it is in this little capsule, little plastic capsule. The powder inside this capsule is sterile also. Now, why am I talking about sterility here? Well, it's because what I'm going to try and teach you is to handle this in a way that you don't contaminate it with your own coliform bacteria and then cause a false positive. So these components are all available commercially. You can put a kit together like I've done here. This contains enough materials to test 25 samples. You can do that for somewhere in the range of $70 to $80, and that's 2018 dollars. And you can use that to train the trainers, to train your teams wherever you're going. So let's start with the components. The powder, which is, they call this thing a pillow for some reason. I don't know why, but I'm going to replicate that. They come in a plastic container like this from the Hach company. Now I'm going to give you a handout that lists all of the components and where you can get them if you choose to. But for $70 to $80, you can put this kit together. So the powder is central because it's growth media and it's sterile. The sample bag is sterile inside, and it's very critical to keep that way. Both of these are very critical to keep that way. So the other components in the kit are Sharpie, fine point. It's a fine point permanent marker, Sharpie. Another component is this PVC fitting, which serves as a makeshift powder pillow holder, and I'll explain that as we walk through it. You're going to need a sharp knife to cut the top of that powder pillow off in order to get the powder into the sterile bag. This is really nothing but a razor blade on a stick because it will cut, and it cuts beautifully, and I'll show you that in just a little bit. As an aid to the sterility, you're going to want to have some alcohol swabs, and these are the alcohol swabs that typically diabetics use when they inject themselves, so those are available at drugstores. One of the final components in the kit are the instructions and a data sheet. The instructions really show you in pictorial form exactly how to put this together. In case you happen to forget, you can whip this out and this will remind you very quickly how to do that. And a data sheet. If you're going to be scientific about things, you're going to want to record your data, and this data sheet is something that you can create. You can create both of these, your instructions and your data sheet yourselves with no problem. Finally, all of it goes together in this fanny pack. And again, I'm going to show you with this handout all of the online as well as local resources that you need in order to put this kit together. So for you guys, I'm going to do this right now while I'm thinking about it. Otherwise, I'll forget it, and then we'll have a mess. We don't need that today. So the very next thing I'm going to do now is I'm going to talk about exactly what you need to do in order to prepare yourself to do a test and then do the test. And then I'm going to walk you through doing the same thing. Okay? So the first thing that you need to be I need to be talking to you about is how do you collect a sample? And remember, we want the sample to represent exactly the contamination that's in the water and not your contamination that you might put in the water. So you're going to find that you're going to be in two places when you're collecting water. And now remember, you're going to be training others to do this. So it's going to be very important that you get some of these things and pass them along. So I'm going to use my Husky razor sharp knife to take a water bottle, and water bottles, by the way, are ubiquitous in the third world. They are everywhere. And that's the kind of water you're probably going to be drinking yourself. So save some of these. So now you're confronted with either a water tap somewhere in a village, or you're confronted with a pond. How are you going to sample the water? First of all, you take your water bottle and cut the top of it off. Just like that. Okay? Now, if you have a stream of water, the smart thing to do is to catch the stream of water, fill it up, let it overflow, and dump it out. Now, what is that going to do? That's going to rinse whatever water was in there, Hopefully it's going to rinse any of your contaminated bugs out of there. And it will represent then the water that you want to test. It will not be contaminated. So you do that like 3 or 4 times. Fill it up, dump it out. Let it run over, dump it out. And then be prepared immediately to set the test up, which I'll do in just a second. The other thing that you're going to want to do is to create, again, using a water bottle, is to create a holder. This is what this thing is going to look like when you're done. If you lay this down, this is a plastic bag that's just held together with wire. If you lay this down long enough, this is going to leak out. You're going to lose your test. So you want to have something to prop it up. So again, you take a water bottle, and about halfway up, you take the top off. Now this is why you need a sharp knife. This is a razor blade. Regular knife ain't going to work it. We used to fool around with pliers to do this, and eventually we gave up on it. They just weren't sharp enough. So you can see now how this is going to be a perfect little water holder when you get your sample ready. Okay? All right. So the next step is to actually take these components and put a sample together so you can see how it's done. Now, remember, we have to maintain the sterility. We have to. We cannot introduce a false positive. It's not okay. So we take the alcohol swab and we sterilize 2 things. One, we sterilize this blade by giving it a good wipe. Now I'm going to use my Sharpie to prop it up so that it doesn't touch anything. We're maintaining our sterility. The other thing that is important to do once you practice this is to move as fast as you can. Why? It's because particulates in the air and everything are dropping all the time. Typically they have bacteria associated with it. They may or may not create a false positive. We're not going to worry about it now because I'm trying to teach you this. But you need to move as fast as you can after you get a little experience. The second thing you sterilize is the top of this powder pillow. Again, they call them pillows. They're capsules, but it's a pillow. They call them pillows. We're going to call them pillows. And you take the alcohol wipe again, and you give that a good wiping. Then you take this little PVC fitting, which is nothing but a 90-degree elbow with a side extension, and you put it in there. Why? Because you only have 2 hands. If you're working by yourself, you got to hold this thing up too so it doesn't get contaminated. So there's a lot in here about contaminating your sample, which you want to avoid. Okay, so now that we've got that done, the next step, remember this is sterile also. The next step is to try and get the powder in the powder pillow here. Now I almost touched the top of that. I trust that you guys noticed that I almost did that. That's no. We don't want to be touching the top of that thing because that's where we're going to make the cut. So this bag has a perforation on the top. You take and remove that, like that, tears right off. And the bag also has 2 small little tabs located on the sides. That allows you to open the bag. So you gently pull those like that. And you can see that that makes an opening. But then you grab one of the tabs again and kind of settle it down like that and open it again like that. So now it's ready to receive the sample. Put the powder in first. You'll go nuts if you do it the other way around because it won't wet right. So I'm going to stick this in our little powder holder for a minute. I'm going to pick this up below where I sterilized it with my alcohol. I'm going to pick up my blade, which has been sterilized, and I'm going to take the top of this off. Maybe. I thought I had a sharp knife. Yeah, I do. There it goes. Okay. So the top is off. I haven't contaminated anything yet. I'm picking up my bag. Now we'd be going lickety-split here if this was real, because leaving that stand that open for that long, stuff is going to drop in it. You don't want that. You want to go as fast as you can to avoid contamination. So notice when I pour this in, I'm not going to touch the top to anything. I'm going to just pour the powder in like that. Okay? All the powder. There we go, all of it. Well, that's the first time that's stuck up like that. There's another reason why you need a little holder to get all the powder out. I've never had one stick like that. Okay, so make sure that all the powder comes out too. That's another thing. You need all of it. Okay, now we're ready to put the water sample in. Now just remember again the order in which we've done this. Powder goes in first, then the water. If you put the powder in after, it's going to float on the top. You're not going to be happy with how you have to distribute it. This is easier this way. It wets the powder easier when it's already in there. So you'll notice that on the bag there are two marks. One says 4 ounces fill line, the other says 100 mils fill line. We're going to go to the 100 mil fill line. This is water that I know is contaminated. It's from Salt Creek, which is a creek that runs real close to my house. I collected this a couple of days ago. Okay, now the fun starts out. You know what? I left out a part. I should have told you to mark the bag with the time and the date beforehand. But in my excitement and exuberance, I forgot to do that. I hope you'll forgive me. But in the meantime, now we have to close this thing up. So the way to do that is that you'll notice that when I pull on the long tabs, it has a tendency to close the bag. That's what you want to do, because what we're going to do next is not going to be any fun if you haven't closed the bag. So close the bag by pulling on it. I've got my water up to the 100 mil line. Now watch. Do you see that? That closes the bag. Now that was like 2 or 3 times. The bag is now closed. But to really secure it now, I need to bend the wires back, as I'm doing right now. Now the bag is really closed. So what can I do with this? Well, I can do this now. And it's not going to leak. But if I just lay it down, eventually, let me tell you, it's going to run out. And you don't want that to happen. So you can kind of pinch the places where the powder has collected. And you can make this whole thing dissolve. And over time, even though it looks like it's a little cloudy right now, that's probably because of other things that are in the water. This will eventually dissolve out. So I'm going to put it back in that container, and that's where we're going to keep it. Yes, ma'am. Question?
Mr. Cross, what does the powder do to that?
The powder is growth media. The main component is peptone, which is common growth media powder that microbiologists have been using for decades to grow bacteria. So that's what's in there. There's a bunch of other things, buffers. There's ferric chloride, which is an indicator. What's going to happen is the coliform bacteria and the indicator bacteria that are in there are going to produce hydrogen sulfide. When the hydrogen sulfide reacts with the ferric ion Fe3 plus 3, it's going to turn black. When these bacteria metabolize, they produce hydrogen sulfide. So in the end, when you have a positive test, it's going to look just like this. It's going to be black. And guess what? It's going to stink. It's going to smell like hydrogen sulfide. Okay, we're going to pass. But everybody can see that this thing is black, and that is because, what's this about here? Oh, that's my lid. So this thing is positive, and it's black, and that's what we want when we want to say we have the presence of the coliform bacteria. Okay? So, one more thing. When you're out in the field and you're training, you might be going from site to site. You might want to get yourself, save a six-pack carrier like this from some beverage that you might have, okay? This is perfect for keeping them upright. Again, you don't want them tipping over, and you sure don't want them falling and making a mess. So you can see, if you went from site to site, you could have this handy in your truck or whatever you're riding in, and even a motorcycle you could do that on, and it'd probably work out okay. And the good thing about this is that you can pack it in your luggage, and it's flat. So, now, the next thing we're going to do is we're going to walk you through doing the very same thing that I did. So, if you would, please open your packages up. You've got your little instruction sheet there. You might want to put that to the side. So I'm going to make you do the thing that I didn't do, which is label this today with today's date. It's Salt Creek water. You've got a water sample there. Salt Creek water. And today's date is the 5th, and the time is whatever it is, 1 something or something. Oh, by the way, these things turn black after 48 hours. I failed to mention that. They incubate for 48 hours at 77 to 95 degrees. If they're positive, they turn black. If there are no coliforms there, they remain in an amber color, just like this. They remain amber like that. So, okay, now you've got your bag labeled. The next thing to do is to disinfect your knife blade and your powder pillow. Now, that's easy to open. This is easy to open, like that. You're going to use, go ahead and get your, go ahead and open your alcohol swab. That's good. And yes, right. Disinfect the blade and then lay it on top of your Sharpie. That's the system. Lay that on top of your Sharpie. And then disinfect the top of the powder pillow with your alcohol swab and put it in your powder holder. That's that little PVC fitting that's a 90-degree side exit fitting. Stick it right down in the top. Okay. All right. Everybody along there? Okay, cool. That's good. That's good. All right. Now, I forgot. You need to make a holder. So you're going to have to go back, take your knife, cut this bottle in half. There we go. That's good. That's good. Great. Set that aside. Now you're going to have to re-sterilize your knife blade. This is great because the real world, this is the kind of stuff that happens. You know, you forget because it's not easy to remember all this. This is, you know, the next thing to rocket science, right? Okay, so you've got your powder holder ready to go. You've got your everything's ready. Okay, so pick up your bag, the bag, and tear the top off. You'll see it's perforated. There we go. Great, 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 great. Now, the two little tabs on the sides, pull those open because that opens the bag. Now, remember, you don't want to get your fingers anywhere close to the top, and you can kind of straighten it out again so that you remember what you're going to do. The next thing is you're going to cut the top off of the powder pillow and you're going to pour your contents into your bag. So, no, don't knock that little tablet out. So, everybody take your little bag and stick it down into your holder. That's good. That's good. You guys are doing great. That's really great. Okay, now pick up your powder pillow. And with your knife, now be careful, don't touch the top. With your knife, cut the top of that off. It's best to start on the short end. There you go. And then pour the contents in, but don't touch the top to anything. Pour them in. That's it. Good. Your powder came out. That's good. All of it. Got to check and make sure the powder comes out because I had one that was stuck in there. That's not a good thing. It's not a good thing. Okay. Now, the next thing is to put the water, put your test sample in on the top and go to the 100 ml line. So unscrew your little bottle there. And then pour it to the 100 ml line. And when it gets there, stop. To the 100 ml line, yep, everybody's good. Good, great. You can recap your bottle if you want. You don't have to for the next step. Okay, now the fun. I'm standing back. Now the fun. Pick it up and pull the long tab because that has a tendency to close the bag. Okay, now remember how I trained you. Give that thing a couple, 2 or 3 spins. Go ahead. There we go. Oh, great. Go ahead, Sherilyn. No, you can do it. You can do it. Go ahead. Yeah, that's it. Shoot it away from somebody. Yeah, oh, great. Oh, super duper, super. Okay, now you have those 2 tabs. Fold those back around the back or the front, either one. And then tilt it back and forth to get the powder dispersed. That's it. You might pinch it a little bit. Sometimes it kind of clogs up on the bottom and things like that. But that, now, you are ready to incubate this thing for 48 hours. Now, sometimes these things go black quicker than that. And that means there's really quite a few bad bugs in there. So you can put this back in, you dropped your holder. There you go. Stick it in your holder. You're ready to go. You're ready to go. Now, if you were doing this at home, and you're home here, I would suggest that if you wanted to find a warm place, it might be near a water heater or something like that, because your home may not be quite 77 degrees. In any case, my experience with this is if the coliforms are there, they show up. It only takes one coliform bacteria or indicator bacteria to make that thing go black. It will do that, and it will do it in spades. And the benefit, of course, is that when you show this to the local folks, they see that this is a dramatic test and that there's something not quite right. Now, a little bit of etiquette. It's probably really smart to ask for permission to test the water. You don't want to go out, test the water, and go back, say, see how bad your water is, and that. No. Find the local elders, church leaders, and others and say, would it be okay if I tested the water? And then you kind of show them the results and then let them talk about it and everything. But don't prance around too much on the front end about how bad their water is. They may be very sensitive about it, But again, the notion of showing the results of this test hopefully will motivate behavioral changes and they will begin to do something. For example, they may want to acquire a water filter, or they may do something else to help purify their water. They may boil their water more often.